So we can see that the feedback is right about there. Generally I find 3 works best for the quick and easy way of doing it, which gives us this result. Hello and welcome to this quick guide. This is a on-the-fly video that I'm doing, where I've just got this video file here that a friend's passed on to me. So basically what it is this is a live gig video file that somebody's asked me to take a look at and try and remove some of the feedback from. Now basically there's a few points where there's little bits of ringing and there's other points where it's really bad, which I'll show you in a moment. And what we're going to try and do is notch these out using free software that you can just download with the help of analyzers that show you sort of exactly where it is if you haven't got the ears to just notch it out and know what frequency it's at. But anyway, here's an example of some of the feedback that's in this video. There's a bit of a ring there. There's a little bit more around here that you can hear, and there's also some more sort of somewhere about here. It's quite bad, I think. So that's quite a high peak there, including it distorting. Now we're going to try and offset this, or at least make it less obvious and harsh. I'm just going to use Audacity for this and FFmpeg. Now the reason I need to use FFmpeg is because this is a video file. So what I'm going to do is I'm going to cut the sound out of this video and just get an audio file, import that into Audacity, work on it, re-export it, and then stitch it back together to this video. And I'll show you how to do that anyway. So basically what you're going to want to do software-wise, I'm going to go to the Audacity website, which is audacityteam.org, and download it for Windows. And you can get the installer file here. Audacity Windows Installer. Save that and run it. I've already got mine installed, so I'm not going to. And then if you are taking the audio from a video, like I am, you're going to want FFmpeg, which you can get that from ffmpeg.org. Just go on here, go download. You want to download package and executable, so Windows build here. Then on this site, you just want to select your Windows version, which these days pretty much everyone's going to have 64-bit. And then static. If you can't run the file when you download it, you want the 32-bit one. And then click download build. This will give you this zip folder, so we'll save that. Okay, so here's that FFmpeg folder that I've just downloaded. And what you're going to want to do is basically open this and extract it, so you can just drag it out to your desktop, for example. And then here's the FFmpeg folder. Within this, you only want one file. You want bin and then ffmpeg.exe. Now, to make this simpler and keep everything together, I'm just going to make a new folder here. I'm going to call it feedback, and I'm going to put the video file in it. I'm then going to open this folder. I'll open the bin folder. I'm going to take this FFmpeg file and drop that in. And that is us done now. So this is how we're going to take the sound out of the video file. So basically once you've got your video file and FFmpeg side by side in this folder, you're going to want to open up command prompt. So on the start menu, just type in cmd, command prompt will come up, right click it and run that as an administrator. Click yes when you're prompted to do so. And now what we're going to want to do is get the folder that we're in and set that as the directory. So click up here and just copy. And then on this command line, what you want to do is type cd, which sets the directory or the folder we're working in. Put a quotation mark. Right click your mouse and it will paste, and then put another quotation mark at the end. Press enter and you can see we're now in C users Nathan desktop feedback. So anything we do now here is working in this folder. So the first command you're going to want is this over here. I'm going to put all these in the description, and you want ffmpeg, which is the name of the program. I is input, and then you put the name of the input file, which is going to be DJI 029 whatever. We'll change that in a second. and then we're going to want audio.wav. Now this is what the file name is going to be called when it pulls just the sound from it. It just strips the sound out of the video and makes a WAV file from it. So I'm going to copy this in. So copy that, and then just click in here, right click, and it will just paste for you. Go back to delete this input file.mp4 section, and then copy your file from down here. So it's called DJI whatever.mp4. Paste that in. Make sure you've got the file name and the extension, and this should work with pretty much any extension. So AVI video, MP4 video, MOV video, whatever format you've got. Then audio.wav you can just leave as it is, because that's just what it's going to call the sound file. And if we put this folder over here, press enter, this here is now stripping the sound, and when it gets to this point it's done, and it goes back to see user's desktop feedback. And now we've got audio.wav and the actual video file. So if we open this, we can hear that's the sound from the video, and it's exactly the same length. So now what we're going to do is we're going to go to Audacity. You can leave this command window open in the background. And then what we're going to want to do in Audacity is go to File, Import, Audio. Make sure you're in the folder where your files are, and open audio.wav. And now this is the audio file that we're going to be working on. This is the sound off that video. Now I recommend you drag it bigger so you can see what you're doing, and also use the magnifying glass and such to zoom in closer. And I know roughly where this feedback is in this file, so what I'm going to do is I'm just going to jump to them points. So our first one is around 2 minutes and 17 seconds, which will go here and zoom in. So right about here we should have that feedback. So I'm going to go a little bit before. So we can see that the feedback is right about there. And what I'm going to do is I'm going to select where the feedback is. So click and drag over it. And then I'm going to go to Analyze menu and click Plot Spectrum. And it'll open up this little window here. So what this has done is it's just listened to that section of the sound, and it's shown us the frequency graph of it. So if you make this bigger, you can see now there's these really sharp peaks. This is generally what feedback will look like, a very harsh, sharp point in the waveform of the file. And this here is by far the worst. Now what's handy about this tool is you can see we can move this pointer around, and if you look at the bottom here, it tells us what frequency we're at with the cursor and how loud it is. Now the main thing we're fussed about is the frequency. So if I mouse over this and the peak, which it should snap to peaks, you can see when I move this cursor it sort of jumps to the point. Here where it's snapping to, this really sharp harsh peak right there, if we look at peak, it tells us that that is 4062 Hertz. So we're going to make this a bit smaller. And what I'm going to do is, with that still selected, be careful not to click off it, go to Effect, go to Notch Filter, and then we're going to set that to 4062. Now Q, this will by default be set to 1. What this does is, the higher the Q is, the sharper the point that it removes is. So you can preview this here. So by default, with it on 1, it'll sound like this. And we can see it's basically removed it, but it's removed other information as well. So if we up the Q value to say 3, we get a bit more of the frequency range back because it doesn't cut as much out. But if you go too high with this, it might not be narrow enough to cut the feedback out properly. So you can hear with a 6 value, it's ringing a bit more. But if with the 3, it doesn't do it quite as bad. Now you could take this up to say 12 maybe. a bit more ringing comes back. Generally I find 3 works best for the quick and easy way of doing it, which gives us this result. So if we apply OK, you can see that the waveform has changed here, and if we listen back to this, you can notice that the actual sound changes when it passes into the point where we've notched out that frequency. That's because that information's now missing, but it has the advantage that we don't have the feedback there anymore. It's removed that, so we got rid of the nastiness. And it's a lot less noticeable now. Now, if you remember this frequency analyzer here, if we go back now, this doesn't automatically update, so you have to close that. And if we go back to this section here, select it and go Analyze and Plot Spectrum, this will open up the frequency analyzer again, and you can see where we went before, that frequency that we've cut out, it's now dipped. There's still some peaks around it, which you always have in music and sound anyway, and just in resonance, but it's cut out that big feedback spike, which is why we can't hear it anymore. Now that was quite an easy one to remove, because it was only one real frequency that was feeding back. Now there is worse in this file, and I'll show you them as well. You have to do multiple cuts if the feedback is worse. So there's a bad bit here. It's a very distorted recording at this point, but we can still do some work on the feedback. So if you listen to this, right there is really bad. Not only feedback but also distortion, but we're going to select that sort of second that the feedback's there for. And what we're going to do is we're going to analyze and plot spectrum again, and we can see this really harsh sharp bit here, but there's also another one at the side of it. Now this is because it's got more than one frequency that's causing the mass of the feedback. So we'll remove the highest, harshest one first, which it says the peak at the bottom is 4067 Hertz again. So what we're going to do is we're going to close that down, go back to notch filter, change this from 4062 to 4067, leave it with a Q of 3 and just preview it. So that's with that, that's without it. So without, with it. So it's reduced some of the feedback, but some's still there. So we apply that filter, and now what we do is we analyze it and plot spectrum again. And now we can see, well you can really see on this, how it's cut that frequency out. But you can see there's still these other harsh ones around. There's one here, there's one here that's probably also ringing. So we're going to remove this one and see what difference that makes, which is 4326 Hertz. So we're going to go Effect, Notch Filter, and do 4326 Hertz. We're going to leave it with a Q of 3. And that's actually made quite a big difference. I'm going to try and make this a bit sharper. See now, a 3 versus a 6 isn't making a lot of difference here, so we could go with a higher Q, which means we'll lose less information either side. So let's try that. And then if we plot spectrum again, you can see that it's made another notch here, but it's even sharper than before. So there's a visual representation of the Q factor. Now you're always going to lose some information because you're basically hacking out the frequency that's feeding back, and when you're doing it to something that's already been recorded, it's just inevitable. So you can hear the difference, but the feedback's not in your face like it was. Let's move to some worse feedback. Yeah, so this is really bad feedback. You can see this screech that's really loud and even distorts. And then it fades here. But basically what we're going to want to do is select just a bit before. And I'm going to select to about here. And I'm just going to listen to that, which is really loud and ringy. We're going to plot spectrum on that. And we can see how massive, like this is quite a large peak. Like it's quite a wide width one. A couple of those we looked at were really pointy and narrow. this, it's got a frequency here, a frequency here, a frequency here. Now, what we could do with this is we could put a few really sharp filters in and try and notch out the individual frequencies, but then you tend to find you can still hear it in between them, and these are so close together anyway. Like this here is 3685 Hertz, this is 3800 Hertz, there's not a big gap. So what I would do is I'd try and find a cue that will fit all of this and reduce it down to maybe about here. So I'm going to find the middleist point of it, which is this sharpest bit. So that's 3805 Hertz. Close that. Effect. Notch filter. 3805 Hertz. I'm going to leave a cue of 3 for now and just listen. So that's reduced it considerably, but there's still a higher frequency ring. This has got rid of the lower frequency one. So if we apply that now, you can see a lot of that waveform has gone. And that's what it sounds like now. So if we analyse and plot spectrum again, we can then see, well, we've notched out them frequencies, but there's still some left either side. There's also this here, which is the higher frequency feedback. Now I'm going to take the higher one out first, which is at 11,303 Hertz in this case. So 11303. And I'm going to go effect, notch filter, 11303, and preview that. I'm going to make the cube sharper. Yeah, definitely needs to be bigger. Basically, if you just play with the Q value here and keep previewing it, you can tell how much feedback it's removing versus how much other information it's moving. So if we can go down to 0.1, which removes loads. 1 is kind of the standard. 3 is how I like to generally do it because it's narrower. And you could go all the way up to, well, 50, which is extremely sharp. But let's apply a Q of 3 to that. We can see it's reduced a bit, but not a lot. And then we're basically going to go and analyse plot spectrum again. We've removed some of that peak here. What I'm then going to do is I'm going to go back to this frequency, which is 3687. And I'm going to go notch filter 3687 and preview it. So we've reduced a bit more of that. And then I'm going to analyse plot spectrum again. This is going to be a little destructive because of the amount of feedback and ringing that there just is here anyway. You can see here there's another sharp, harsh peak right at this end. I'm going to try and remove that one. That's at 18,923. So 18923. So before. And then notch filter 18923. That's not really making much of a difference, so I'm going to make this quite sharp. And then I'm going to reanalyze it. And I think here's probably going to be a rather offending one, which is at 7,493. So 7493 we're going to notch out. I'm going to do this with a Q of 3 again. That's with that removed. That's without it removed. That's with it removed. So it's making a bit of a difference. Okay, so I've been through this a few times, just listening to it, analysing the frequencies, and notching out a few frequencies, and I've got it to a point where it's not as harsh as it was, but there's still some feedback there. Now, I don't want to remove too much because, as I say, you just keep losing information from the actual original audio. I just want it to not be as in your face. So it's now more like a bit of a light feedback with a bit of like a fart and crackle. So you notice that difference there in the sound. That's why we've cut a lot of the frequencies out. But this is such a loud, wide piece of feedback. we can't just remove that one frequency like we could before. So that's probably as well as we're gonna get. We could reduce the overall sound of the file as well if we wanted to, but I'm not going for perfection on this. This is just more of a quick proof of concept thing than anything. You could spend more time and dial stuff out, but your mileage will always vary doing things like this because it's just the way it is. Unless you get it right first time when you record something, like there's no feedback in the first place. Anyway, that will do for this video because it's not a massive problem that it's got those little niggles in it. So for the most part, that's okay. We're going to export this now though and stitch it back to the video. So we'll go export as WAV, and then we're going to export it into the feedback folder again, and I'm going to call it fixed audio.wav, and I'm just going to leave it as WAV signed 16-bit and save that. Can clear that information, but you don't really need to. And we'll close Audacity down. We're done with that now. And we've got fixed audio and audio now, and you should notice at the bottom, if you've left it at 16-bit WAV, it should be the exact same size file above 41.5 meg. This is the original, and this is our fixed one. So if we listen to the original, and we go to where it's particularly bad feedback, which is sort of like... so what did we do? We did about 217, I think. So on this one, that's the same bit. So we can see you can't really tell that the feedback was there. It's distorted video anyway, so the sound quality is not brilliant. But because that was only a small, shorter ring, we could cut it out easier than the big, loud, distorted feedback rings. So there's another one. About 618, 619 on our fixed one. You can see that the sound dips in quality for a little bit, but there's not really anything we can do. It doesn't blast and deafen you with feedback anymore. So now what I'm going to do is show you how to stitch this sound into this video file. Just basically replace the original sound. So what we're going to do is we're going to use FFmpeg again. Still got command prompt open from before, but you're going to want a different command. So that's this one. Again, these will be in the description. It's FFmpeg again, input, original video name, and then input, fixed audio.wav, which is what I happen to have called my file. So if you call yours that, you won't need to change it. And then CV, which is copying the video, basically, because we don't want to re-encode all the video file that'll take forever. What it does is it copies the video as it stands and stitches audio together and calls it fixed video.mp4. Now you're going to have to change this to whatever format your video's in. So if you've got a MOV that you're doing this with, you're then going to want to put this to MOV, or if you've got an AVI, you're going to want to put it to AVI at the end. Keep the extension name the same for your files. But copy this command, paste it in, and then what we're going to want to do is get the name of our original video file, which is this DJI whatever.mp4, and we're going to use the left arrow, go in, and we're going to get rid of original video.mp4, then right click, and it pastes in the file name. Fixed audio.wav is what mine is called, so I'm going to leave that there, that's right. And then mine's going to be called fixed video.mp4 in this case. I'm going to delete fixed video, and I'm just going to paste that file name again, but I'm going to go back and change it to fixed _ DJI 299 and press enter. And then what this is going to do is it's going to take the sound file that we have fixed, the original video, it'll delete the sound off the video and stitch this one to it. So when it comes to this point here and says see users desktop feedback again, that means it's done. you'll have a video file in here. It should be the exact same size as the other one, you can see down there. So if we look at both of these now, you'll see that we've got the original, and then we've got the fixed one. But if we go through the video, so here's some feedback. And then if we look on our fixed one, the feedback's not there because we've notched that out. So the same towards the end. So there's that really harsh feedback, about 6 minutes and 18. And on our fixed one, so we lose that for the second where the feedback's been cut out, we lose them frequencies. But in the grand scheme of things, it's not too bad. It's not as shocking as it was, and we've now got a passable quality video file. It's not going to be perfect, especially with the loud distorted feedback that was in this file. If you've got a better recorded video that the audio is not distorted on, you can generally cut the sound out a lot easier, as we saw with the quieter parts where it was just a little bit of ring here and there. We cut that out quite easily. But yeah, that's basically it for this video anyway. It was more as a rough practical demonstration. You now know how to find the frequency peaks using Audacity in the file, and it's just a case of trial and error notching them out. Not all peaks are necessarily feedback. Some of them are actual intentional, say from a performance standpoint. So if you've got a better recorded video file or audio file that hasn't got the distorted, loud, really like harsh feedback in it, your chances of removing it completely without causing any real audible damage to the file is a lot better. But it's just a case of using them tools in Audacity, analysing it, trying to notch a frequency out, so like listening to it using the preview function. If it doesn't make a difference, try changing the Q a bit. If you have to put the Q too big, you've not got the exact right frequency. So yeah, I hope this video has been of some help to you. If you found it useful or helpful, please leave a like down below. Any questions, put them in the comments section, or if you need any help with anything, I'll try my best to help you out, or anybody else watching this video. If you see someone asking a question that I've not replied to, feel free to try and help them out as well. Let's just try and all help each other out. And be sure to subscribe for future random videos like this one. Thanks for watching.